to see how to calculate Six Sigma matrix in internal quality control using the data which is already available in the laboratory. Example of process improvement for clinical laboratory. We will see the same example again. So first of all, you need to select the analyte, for which we need to find out the current processes of Six Sigma and the target scale of Six Sigma. So select the analyte, define the goals on Sigma scales, and now as we know there are no direct reference method to find out the defects. Here we are going to find out the bias for that analyte, the total allowable error for that analyte, and the CV percentage of the analyte. Using this you can find out the current sigma score, and once you have found out the current sigma score, depending upon the sigma score and the goals which we have formulated, we need to formulate the QC plan. After formulating this QC plan, you need to implement this QC plan and verify the performance using the newly implemented QC plan. This is how statistical quality control can be formulated using Six Sigma methodology in internal quality control. Or to formulate the IQC plan. The objective of statistical quality control is to achieve high level of error detection and a low level of false rejection with the simplest control rules for the least number of controls. So we do not have any easy comparative value against which we judge the test result. So we are dependent on the data which we are already collecting, which in terms of imprecision, trueness and total allowable error. So the sigma matrices can be calculated using the formula where the sigma matrix is equal to total allowable error minus bias divided by the standard deviation or CV percentage. So the sigma matrix will be calculated as total allowable error in percent minus bias in percent divided by the CV percentage. So how to determine each of these terminologies or how to determine values for each of these parameters, we will see one by one. First of all, let us see the total allowable error. Total allowable error may be defined by the criteria for acceptable performance for EQA or PT surveys. So the total allowable error values can be directly collected from the EQA surveys or proficiency testing surveys. It can be also collected from peer group based EQA data or accuracy based EQA data. The report, at the end of the EQA report, the proficiency testing program will be defining or has total allowable error at the end of the report, which will be used for the calculation of sigma matrix. There are two types of EQA reports are available. One is peer group based EQA, whereas the other one is accuracy based EQA. So from this you can calculate the total allowable error for the parameter you have selected. So total allowable error can also be taken from the CLIA guidelines or the calculation of sigma matrices. The next step is to estimate the bias. Now this bias can also be estimated with the two different approach. One is the comparison of method experiment which the laboratory performs in-house during the performance verification or the test verification process, where the laboratory has already performed the bias experiment or accuracy experiment. So the bias can be collected using the same experiment. The next option for collecting the bias of the specific analyte is to use the EQA data or proficiency testing data, where the laboratory's report is compared against the reference method or peer group of the survey group. So from the PT program or the EQA program, the bias can be calculated. So we have two options for calculating the bias. One is specifically from the comparison experiment or the performance verification experiment which the laboratory has already conducted in-house while introducing a new test in the laboratory. And the second one option is to collect the data from EQA report or proficiency testing report, where the laboratory's report results are compared with the either with the reference method or with the peer group data. And finally, the last parameter which we require for this sigma matrix calculation is the calculation of the CV percentage. Now this CV percentage can be calculated or can be obtained using the replication experiment which the laboratory has already performed using while introducing a new test in the laboratory, which is a performance verification or test verification data, where the laboratory already performs the precision experiment and collect the CV percentage data. The next option is to collect the data from the day-to-day activities or day-to-day internal quality control data. So again, for calculating the CV percentage, the laboratory will have two options. One, to collect the CV percentage data from the laboratory's test verification process data, or the second option is to collect the data from the internal quality control. So here CV percentage can be calculated using the standard deviation divided by mean into 100. So this is how we have collected all the three data for calculating the sigma matrix. Total allowable error is required, which can be collected from the PT programs or from the CLIA guidelines. The next is the bias, which again can be collected from the PT program or from the in-house experiment for the bias calculation or for accuracy, which will be conducted during the introduction of the new test in the laboratory. And the last parameter here required is the CV percentage, which can be collected again from the replication experiment or precision experiment which is performed in the laboratory during the method verification process before introducing a new test in the laboratory. And the other option for collecting the CV percentage is collecting the data from day-to-day IQC operations or day-to-day QC performance. So this is how finally we will come to the conclusion of sigma matrix in a laboratory. In the next video we will see a actual example how to calculate the sigma matrix for a given parameter. Till then,